created. Okay, so what is happening? This document, this corpus is being converted into a vocabulary, that is a document of words internally, right? So each and every word is separated into tokens, and that tokens are stored inside this list. Now that particular token is counted every time. Now see, for first document we have this corpus. So corpus first document is natural language processing enables computers to understand human language. This is our first first document in this corpus. So it is going to count the occurrence of each and every word. See, for this document one, natural comes one time, so the occurrence is one, language is one, processing one, enables computers to understand, all these are one. And other tokens it has not taken. For example, two it has not taken. It is only two which I think it has not taken, right? And similarly, the vector that is generated for document one, if you see, so for entire document one, based on the presence or not presence, the position, see the frequency of words, the vector will be 0010 and so on. So you can see the entire vocabulary. In this vocabulary is matched with the tokens. So you can see and are commonly, they are not present here. Okay, computers are not present here, computers is present. So you can see here and are commonly, these three words are not present in this first document. Only it is computers that is present. So fourth word is one. So you can see here first three are 00 then one. Okay, so this vocabulary is matched with these tokens, and wherever the token is present, that token is counted as one. And in this vocabulary where these words are not present, they will be marked as zero in this entire vector, right? So this is how, vectorization is happening. So vocabulary is being created, then each and every, that you can see here also in our execution, you can see here also, this is just the document one. That means the first, you can see this entire thing is converted into 15 words, and for first document we are creating 15 positions. So the vocabulary that we have is creating over here. Just see here. So let us start matching. Now this is the vocabulary, the feature names that are being used. So now this vocabulary will be matched with this first document. Okay, we have to match with it. So about is not present, so in the first thing it is 0. Okay, next an is not present in the first line, so an is also 0. Then one is present, because fascinating, this word is present in this first document, so it makes it 1. I hope you are getting this. Okay, important, again important, this word is not present in this first document, first line of the corpus, so it is again 0. In is also 0. Okay, is present, so is present here, so it makes this as 1. Okay, and then in is also present. Sorry, language is present, so language makes it 1. And then learning is not present here, so learning makes it 0. Okay, so you can match this entire 15 words matched with this first line. Wherever you feel that the match is there, the one will be assigned to that position. Okay, I hope that makes sense for everybody. So there are 5 words in this complete first line, so there are 5 ones that you can see at different positions, based on this this corpus that is being created, based on this vocabulary that is being created. So there you can see each and every one based on the presence, right? Okay, similarly the next, okay, 15 positions next time in this, they will be matched with the next line. I love learning about NLP. So wherever you will find this, just see, it is now using love instead of loving. So wherever it will find love, so it will place it 1. Okay, so first word was about, so here about is present, so you can see 1 in the first position. An is not present, so an will be 0, and so on. Okay, so I hope you are able to match it, you are able to get this, like how this vectorization is happening, how this vector is being created. So you can see this vector contains entire number of values based upon your based upon the presence of each and every word, the frequency of occurrence of each and every word in this corpus. So it is converting this entire corpus into this two-dimensional matrix, two-dimensional array, you can say. So Just give me a check. Is it okay? Did you get it, everybody? Are you able to get this? Okay. I hope you are able to get this. Yes. Thank you,
Yes,
Ramadana ma'am. Thank you for the check. Yes.
yes, ma'am.
Okay. Great. Fine. Thank you so much for the check, Dr. Madhvi. Thank you, ma'am. Thank you, Sonia, ma'am. Okay. Fine. So we have got this particular thing. Okay. Now the next thing, the next concept that we have is TF-IDF, right? Let us talk about TF-IDF also. So TF-IDF means term frequency inverse document frequency. It is a statistical measure. Basically, we can take a complete 1 hour class or 1 hour lecture on TF-IDF. But as far as the main concept is concerned, it basically means the importance. Now you have converted the data, the text into numbers. You have done this, but you have not attached the importance factor to it. You don't know how much a word is important, because if you see here, if you come back to the documentation, to the implementation, you can see we have 0 1 everywhere. We can see only 0 1 0 1. Sometimes sometimes 0 1 2 may also be coming if the word keeps on repeating, and we have in a single line we have 2 3 times the same word being repeated. So you may find 2 3 numbers also present in the vector. So we can see all these terms as 0 and 1. There is no importance attached to it. So just to make some important words to be highlighted, just to have that that importance factor, that catchy factor attached to each and every word, we use TF-IDF, which evaluates the importance of the word in that corpus, in that document. Right? So TF-IDF is a statistical measure that evaluates how important a word is to a document in a collection or corpus. So we have these three. This word TF-IDF is made up of these three terms. TF means term frequency. It measures how frequently a term occurs in a document. In that complete corpus, how many number of times that has occurred. So based on, the more the number of times it is occurring, its frequency, that term frequency will be more. And how it is calculated, it is, we don't need to calculate it manually. Okay, we are going to do it through class and through the calling of functions. But if you want to statistically calculate it, the formula states number of times term t, or that text t appears in the document, divided by total number of terms in the document. So that simply gives you the term frequency, the frequency of the occurrence of that particular text. Okay. Similarly, we have inverse document frequency, which measures how important a term is in the entire corpus. Okay. So we are not now, we in this term frequency we were calculating only in that particular line, in that document, in that sentence, in that corpus. Right? Now inverse document frequency means that importance in the entire corpus, entire entire paragraph, you can say entire list or sequence of that paragraph. Right? So how we calculate that? We calculate that through calculating logarithm, by logarithm of total number of documents divided by the number of documents containing term t. Okay, so this inverse actually refers to the logarithm portion. So it is telling you how important that word is inside, not only in that document, but in the entire list of documents. So the formula is logarithm of total number of documents divided by the number of documents which actually contain that term t. Okay, so it is finding out the inverse or the logarithm part of that importance factor. Right? And TF-IDF, if you combine that, then that means you are just using these two terms together to increase the importance factor. And when I say increasing the importance factor, then that means we are not adding it. If we want to increase the importance, if we want to highlight or get the maximum importance of that particular factor, then we need to multiply टू थिंग्स. अगर हमें मैक्सिमाइज करना होता है कभी भी, मैथमेटिक्स का रूल है, अगर आप मिनिमाइज करना चाहते हैं तो आप समेशन कीजिए, अगर आप मैक्सिमाइज करना चाहते हैं तो आप प्रोडक्ट निकालिए. सो वी वांट टू मैक्सिमाइज एंड हाईलाइट द इंपॉर्टेंस ऑफ दैट पर्टिकुलर text data in that document, then we need to maximize it. So we are going to multiply it. So TF-IDF is nothing but this is a compound which is created by multiplying TF, that is term frequency, multiplied by inverse document frequency, IDF. So that is why this is known as TF-IDF. TF, term frequency and inverse document frequency, they together, when they are when you are product them, when you are multiplying them, they together give you the maximized importance of that particular text word in that complete document. Okay, let's see. These are all, mathematical statistical approach. I cannot go, time is limited, I cannot go into details of all such stuff. Okay, but I can show you how we can implement that, how we can calculate that in our execution. Okay, let us see through code how we do that. Let us see. So calculating TF-IDF, how we are going to do that? Simply by using scikit-learn. Again, all this is a numeric or statistical approach, and it is required for machine learning or text applications, right? So we are simply using scikit-learn. So from scikit-learn.featureextraction.text, again we are using the same library that we used earlier in when we were using this bag of words, right? So we are using the same library here, TF-IDF, right? Scikit-learn.featureextraction.text, import TF-IDF vectorizer. Now here, the class that we are using is TF-IDF vectorizer. That here, earlier we were using count vectorizer. That was count vectorization. Now here we are not just simply counting things. We are not entirely creating only bag of words. We are creating a vector which contains importance. So we are creating an array. I'm telling you, when I say a vector, in vector, see, in statistics, in these data analytics domain, these terms, vectors, tensors, they all refers to numbers, they all refers to arrays and matrices, right? So we are referring here vector as array which contains importance, which contains frequencies. Okay, so the corpus is again same. Natural language processing is fascinated, it is implemented in R and Python in both languages. So we are doing this, the same example we are using. So now we have to call this TF-IDF vectorizer class. So we are creating an object of this class. We are calling the constructor of this class. So TF-IDF vectorizer is the name of the object that I'm creating. So here, after we have initialized this particular object, we need to transform the corpus. So we are using a TF-DF vectorizer. I am using this object and I'm calling fit transform just to apply this vectorizer object onto the corpus, the same way that we had done previously. And after this is done, what is created is x underscore TF-IDF. So earlier I was creating this x, right? Now I have named it as x TF-IDF just to differentiate things. Okay, so here it was just 0 and 1. It was based on the presence or absence, but now it is based on the importance. It is calculating the frequencies of occurrence of each and every word. So just see here, when I am printing TF-IDF array, xidf.toArray, again I need to convert that vector into an array, two-dimensional array, so that I can see that on screen. So you can see this two-dimensional array being formed over here. But now it is not 0 and 1. It is based upon the presence, or it is not simply based upon the presence and absence, but rather it is based upon the frequencies, the number of times it is present, right? So you can see here, and both these two words are having very less TF-IDF factor, so it is 0 0.0 point something, so you can assume it to be 0 0.0, right? Fascinating. Again, this is something which is important. This is highlighting something. So it is having a factor of 0.47, again implemented, again 0 in 0. You can see each and everything. So it is based upon, these are the feature names, and based upon they are present in this, each and every line of the corpus, based upon the presence or absence and their importance, the number of times they are occurring over the entire document, you are creating this entire two-dimensional array. I hope that makes sense. But this time there are two documents only. This is the first document, that means the first sentence, and this is the second document, that is the second sentence. So you can see two rows inside this particular 2D array, right? And feature names are these one that have been extracted for use. So, and both fascinating, implemented in its languages, natural processing and Python. So it is considering each and everything which it finds important, right? Okay, so I hope this is done. I'm just giving you this entire code so that you can execute it if you are unable to do that, or you are facing some issue in it, right? So I have given you that code in the chat box, and previously I think I forgot to give you this code of bag of words. So I'm just passing this code of bag of words also. So in case you are unable to execute that, or you faced any issue in it, you can directly do that, right? I hope that is okay. Are you able to do this? Everybody, please just see to that. You're able to do that. Okay. Okay. Fine. Uh, Rest we have word to vector, and we have NER. Okay, so let us wind this up very quickly. Uh, I'll just give you this entire document because this entire document is very long. It contains a lot of stuff that you can understand, that you can work upon. But I need you to move on to something very relevant, very important, which is the project development. Okay, so I want to take you towards project development task. So I'm just quickly winding up with word to vector. For implementing word to vector, okay, let us talk about the word to vector also, because I think we have not talked about it. Yes, it is about word embeddings. So word embedding means, word embeddings are the dense vector representation of words that capture their meanings. Now, not only the frequencies, but when we are talking about word embeddings, we talk about their meanings also, relationships also, context also. So they are taking more information. So word embeddings are more accurate representations of words. They are more accurate representation of numeric representations of words. Because in bag of words, you were just taking into account their presence or absence. Then in TF-IDF, you were taking into account their importance or their number of times they are occurring in that document. Okay, the importance was based upon only one thing, that was number of times they were occurring. But now when we are talking about word embeddings, there are two representations. One is glove, one is word to vec. So if you are using word to vec, SIBO or skipgram, you're using these kind of algorithms, then they are going to capture not only the occurrences but the meanings, the semantic relationships, the context, everything into account, and then they are calculating a vector for each and every word. Okay, so word embeddings are far more elaborative, they are far more big, uh, you know array which is calculating uh, each and every vector based on so many aspects, right? Let us see how we are doing that. So I hope nobody is nobody is having any issue in it. Okay, thank you Sonia ma'am for the check. Okay, fine. So when you're talking about word to vec, we are using gensim library, right? So gensim library is used to train a word to vec model on a simple corpus. Okay, so whatever simple corpus or simple sequence of sentences we have, we use gensim library to train our word to vec model. So for this we have from gensim.models import word to vec. So we are using this library gensim.models, and we are importing this class word to vec. So this name is word to vector. The entire name is word to vector based on so many important aspects. So we have this corpus. Now I have named the corpus as sentences. So you can see this sentences corpus is in the form of two-dimensional array itself, so that it can easily create a complete array from this. So in general, you can give it in any way, but I have given a more basic way. I have given it in a more simpler way so that it can easily take it. Otherwise, I need to first tokenize it and then convert that two-dimensional token and then use that token into word to vec. So I'm not using all those steps. I have already shown you those steps. So I'm just directly taking this entire 2D array of tokens for this vectorization. Okay, so I'm now creating a model word to vec. You can see I'm using this word to vec class that we have already imported from gensim library. Okay, and then we are passing certain parameters to it. So each parameter is very important. The first parameter is the corpus itself. So it represents sentences. So sentences, here is the corpus. So we have to first pass on that list of words, that sentences, entire corpus. Then we need to give the vector size. Okay, so that means how much dimensionality you need, how many how many factors or how many importances you want to check for the vectors. So vector size in general refers to the dimensionality of the word vectors. So I am going to give it 100. Otherwise, by default it is better to give higher values to just see how many you can say the dense you want to make. The more dense your vector is, the more aspects you want to check, the more values you can check, it is better. So vector size you can give the to increase the dimensionality, just give, a bit 100, or say if 150, 200, you can give these and check, experiment with them, right? So window is 5. Window means the maximum distance between the current and the predicted word within a sentence. So it is just predicting, okay, what can be the most important next word to this word. So based upon that importance, okay, so you are taking that window, the maximum distance of checking of words is 5. So you can check among 5 words. So it is based upon like how many words I have. So maximum I have there 3 words, then I have, here approximately 6 words. So that is why we have given a window of 5. Otherwise, it depends upon the model that you are creating, the corpus that you are giving. So you can assign window accordingly. Okay. So it will check for the similarity for the importance factor, because I am also predicting the important words, the similar words, okay, based on the Jensen models. So workers, next is min count and workers. So min count ignores all the words with total frequency lower than this. So minimum count I'm giving 1. So if you give it 2, 3, then it will only consider those words which are at least coming twice or at least coming thrice. Now I have given it 1. That means, because we have a simple application here, so that means no word which is having count less than 1 will be used. So that means each word will be used here, because each word is existing at least 1 times. If you give it 2, then only those words which are occurring 2 times will be considered, only 3 times if you give 3, 5 if you want, maximum occurrence, you want to check those words. Okay, so based on the applications, you can give values to the min count. And workers means number of thread, because here, each and every vector is generated based on thread means a small process, small executable process, it is converted. So we are trying to form at least 4 threads from it. You can give, 5 threads, 7 threads based on your usage. But generally, whatever window you give it 1 less than. So window if size is 5, then number of threads that you may be using maybe 4, right? So you can give at least, less. You should give less workers when comparing to window size. So 1 less than or 2 less than, you can give it anyways, and you can experiment with that, right? So these are hyperparameters. Actually, these parameters are hyperparameters that you can tune, that you can, change, and you can tune, optimize them to bring to a more better results. Okay, so you have to, keep on checking things and keep on experimenting and fine tune these parameters to get better results, right? Okay, anyhow, now what I'm trying to do, I'm trying to create a model. Now here you can create model on, on each and every word, but I am trying to generate a model on this word NLP, which is repeated 2 times. Okay, so here I am creating a word vector. So word vector equals to model. So I have already created this model from word to vector for this entire corpus. So now I am creating a word vector. I'm going to vectorize this, and I want to see the importance of this word NLP with each and every word. So for that purpose, I'm vectorizing this word only and calculating its importance with each and every other word. So word vector equals to model dot WV, and here I'm giving this word NLP. So word vector for NLP. Now you can see here the word vector. Now this NLP is, matched and compared for importance with each and every other word present in this corpus. So dimensionality, it has taken 100. So 100 aspects it is taking, it is calculating it, and you can see 100 values, 100 dimensional values in this vector. Okay, so that means it is, iterating itself. It is iterating itself in 100 values this word to vector. And now the next application says that, can you predict based upon, after you have created word to vectors, you have taken importance, you have calculated the correlations between the words, you have calculated importance of each and every word. Can you predict similar words? Can you find that relationship where one word similar you can find to another word? That relationship of similarity, can you find? The answer is yes. So we can use the similar words. I am creating a variable similar words, model.wv. I'm again using the wv property of model, and I am using the most similar function of this property. I'm using model.wv dot most similar. So most similar will find the most similar or most resembling word to this word. I've given, suppose, say fun. This word is present over here. So in this entire corpus, I want to find the most similar relevant word which is matching to this word fun. And top n means how many number of values similar you want to find. So just want to find one word. You can give it two, you can give it three. So it will keep on finding the most similar and important word when compared to this fun. So when I run this, when I try to print this similar word, see what exact word I'm getting. I'm getting this entertain. So which is obviously a more similar word to fun. Okay. So you can see here the most similar word to fun that I have retrieved is entertain, and the similarity factor is 0.14. So just understand this thing, that similarity, this word to vec, it ranges from minus, in minus ranges to positive ranges. And the more positive value you have, suppose you have here 0.14, the more positive value you have, that means there is a more strong relationship or similarity index between the words, right? So this is how it is happening. So when I'm using model.wv, it is itself creating this word vector, and then it is finding the similarity of this word with other values, and it is giving you the most, the top most value which is similar to this fun word. So that is entertain. Okay. So I'm just giving you this entire code. You can just execute this. You can learn more about it, right? You can build upon the knowledge that you are gaining today, and you can just, work on it, right? Okay. So I have shared this code with you in the chat box, and you can, execute it, and let me know if you are facing any trouble into that, right? So NER, the next thing is NER. This is the last component that I am discussing. Other components are easier, so you can just go through them. I will stop at NER, and then we are going for the project part, right? Okay. So NER refers to named entity recognition, because we have each and every word refers to some other entity, and there may be groups of values that we may be having. Okay, let us talk about NER also. So we have this NER refers to classifying the entities. So we may be having n number of entities. Let us see how many entities we can have. So we can have these all common types of named entities, right? Just give me a second, guys. Okay, so in NER, we have all these common types of named entities. Okay, so you can see person, like for example, if your text contains some eminent person's name, or it can recognize that name as a person's name, then definitely that will be categorized as person. Or ORG, that means organization. Location, if it is a specific location, a very named prominent location. Otherwise, if it is a country, then country is referred to as a geopolitical entity. Like we saw it in the morning, where we were trying with the textbook tickets for New York. So it was representing New York as a geopolitical entity. Similarly, we have date. Okay, next Monday or weekdays or everything is regarded as date. Similarly, time, if you are giving it in some AM, PM, all that is in time. Money, dollars, euro, if you are using some currency. Percent, if you're using percentage symbol, or ratios you are using. Similarly, quantity, ordinal, cardinal. Event, if it is something very relevant, even like Olympics, right, like national games or world war, or something very very relevant event that has occurred in the history, then that can be taken. Or work of art, Mona Lisa, War and Peace, some sculptures or some paintings, or anything related to art, that can be regarded as the category of work of art. Similarly, product category, products like iPhone, Tesla model, or car models, or something like that. Similarly, languages, English, Mandarin, French, all these are language categories. So these are common named entities that can be recognized by your system and classified accordingly, right? Let us see how we can do that. So a simple example would be, you again need to use Spacey for this, because these are, these are text-based things. So text-based things are done in a good way by using Spacey. I use always Spacey for simple, simple executions and NLUs. So these are all NLU parts. Okay, so we don't need to generate anything. We're not creating anything. So for NLU part, understanding part, we can simply use Spacey. So NLP, I'm creating a you can say a variable Spacey dot load. Again, I'm loading this. Before we can use Spacey, we need to load that simple model of English. So Encore WebSM that we had done in the morning also, we are creating a doc out of this variable. So we have this Spacey. Now we are giving this variable, uh, we are creating a corpus, or say a document out of it. Okay, so Tesla is looking at buying UK startup for $1 billion. So now again we are printing the same thing that we had done in the morning. We are using the entities in the document. We are printing the documents entities. So entities dot text will be like Tesla. Again, UK is, again, this UK is also taken to be a geopolitical entity, that is a country. Tesla is an ORG, and 1 billion is taken to be amount, so it is money, $1 billion. Okay, so this way it is picking up nouns and classifying them into named entity, because noun is nothing but a named value. So each and every noun will be classified into a particular category. Okay, so I stop here with the components or the pipeline part of NLP. Rest you can just you can work upon that yourself. Now the most important thing is, we want to start with okay. Everybody, please install this particular text BLOV, because I might be needing this library. Everyone, so please install this library. This is used for calculating sentiment, positive sentiment, negative sentiment. You can create entire project for sentiment analysis, but by using this text BLOB class, you can at least calculate a hint, a pinch of the factors which refer to how much positive factors in that sentence you have, how much negative factors you have, and how much compound sentence factors you have. So this text below can easily give you that sentiment part. Okay, so everybody, please install this. In Google Colab, you need to check whether you already have this or not, but otherwise in Jupyter Notebook, you can simply install it. So I am just giving you this pip command. You can just as it is install this blog. Okay, so from blog, from text blog, import text blog. So I have used this library text blog, and from that we have a class. So there's just a difference of uppercase here. So this is class by the same name as the library text blog. So I'm giving a text, say I love NLP, and blob, I'm creating an object for this text blob class. So text blob object. So this will obviously give you the sentiment part, the explanation of what sentiment or what feel could be there in this sentence. Okay, so sentiment equals to sentiments, we can just print as blob dot sentiment. So this blob object can print the sentiment part. So just see, if I just play this, if I just run this, first of all it will install the things, and that sentiment will be polarity 0.625 and subjectivity 0.6. First of all, just try to implement this. Are you able to install this? Just give me a check. Everybody, please give me a check. Are you able to do this? Okay. Yes, it's already available in Google Colab. Great. Installed. Okay, Dr. Mavi, thank you so much. Rest of you guys, are you able to do this? Just give me a quick check. Okay. Yes. Okay. Thank you so much, Gayatri ma'am. Thank you so much, Dr. Madhvi. Thank you. Thank you, Sonia ma'am. Right? Okay. Thank you for the check. Okay. Let us now talk about the output, the sentiment that it is giving me. Okay. You have also implemented this. So now it is going to give you, when you are just printing the sentiment, it gives you the output. The sentiment says polarity 0.625 and subjectivity 0.6. So polarity means the overall, say the overall, the feel, the overall sentiment of this entire text. Now polarity may range between, it may range between -1 to 1. It is, negative and positive, so the maximum range that it can have is between -1 to 1. So the more negative polarity you have, okay, जैसे होता है ना negative pole and positive poles, वैसे ही आप कुछ समझ सकते हैं polarity को. So the range is -1 to 1. The more it is towards the negative, towards minus values, -1 values, the more disgusting or more bad taste or more awful, more anguished kind of uh, anguish or bad feel you can feel from polarity negative. Okay, these words if are used in giving your text. And if it is positive, a score, if you can say a score of polarity 1 means where you are using good words like good, a healing, or you can say love, or happiness, that kind of words. So I have used here the word I love NLP. Okay, now if I use it, say I hate, fine. So I just play this. Oh, I should have done it in the next. Okay, or requirement already satisfied. Now it is trying to print the sentiment. It may take a. It is not printing now. What happened to it? It is not printing. Just let me check it. Let me just copy this in another, and I try to print the sentiment. Okay, now it is printing. Just see, I hate. I have used this word, I hate. Okay, I have used this word hate. Now the polarity is totally negative. It is used towards the highest, polarity of negative part. So the polarity is -1. And when I was using, good words, happy words, the polarity was more towards the positive approach. Okay, so this means polarity is showing you the overall sentiment of that text, the overall feel of that text. Fine. I hope the polarity part is clear to you. Fine. And now coming to the subjectivity. Subjectivity means how much importance or the emotion, or you can say the factual information is being given by this particular text. So you can say overall this sentence, I hate NLP, this is giving a factual information that this person, this user doesn't like something, very, very strong feeling. So subjectivity comes in the range of 0 and 1. So I just mention it over here for your reference when you will read this afterwards. So polarity gives you the overall feel, and the range is between -1 to 1. So the range comes between -1 to 1, right? And in the same way, if we talk about subjectivity, subjectivity means overall factual information, like how much appealing this is, right? So how much appeal or how much information it is giving, right? So that range is between 0 and 1. So if you can say here subjectivity, the range, the value is 0.9. That means this entire three words are very much informative because they are strongly representing the distaste or the awfulness or the the bad feeling about something that a person is giving, the opinion that the person is giving. So that this is a very factual information that is being given by this sentence. I hope that makes sense for everybody. You are able to understand the sentiment part, how simple two lines can give you simple sentiment analysis of a particular text. So this is done by text vlog. Okay, I hope that makes sense for everyone. So I'm just giving you this entire code, so you can just run it and see are you able to get it or not. Okay, so I have given you this entire code. Just check, are you able to get this, are you able to implement this, and are you getting a better result from this? Okay, just check this, right? Okay, now I'm just leaving entire thing. Okay, and I'll come to text classification project. Okay, are you done with this? Are you able to find the sentiment? You can just give any text, you can just put in good words, bad words, and check from it. Okay, this will give you, and if you train, because sentiment here is all about, good or bad. This is a simple sentiment analysis that we are doing for good or bad, right? But when you create a project, you can create your own sentiment analyzer, where you can train your machine to calculate sentiments based upon the training. Okay, if forensic science, let me talk about some forensic projects that we have. So in forensic projects, you can directly train your model to detect the presence of that crime sentiment in that text, or crime sentiment in those tweets. Now you may be wondering, like, how cyber crime units or cyber cells, they detect this anonymous activities and very very suspicious activities through the social media posts, or through images, or through the text that or SMS they are sending, or through messages that are being passed on WhatsApp and so on, other social media. So the basis is this sentiment analyzer. The machines are the softwares are trained, the applications are trained to continuously scan through the images, or the posts or the text that are being passed on from suspicious social media accounts, so that you can detect if some suspicious activity is being done, or the crime sentiment or terror sentiment is there, or some sentiment which may be leading to harm the society is there. So all the applications, all such application projects, if you are researching upon those, then the basis of all those projects are nothing but this sentiment analysis that we have done in two lines, that can be extended into a complete project based on some specific sentiment. Okay. Okay, Ramita ma'am is asking for a subjectivity and polarity part. Yes ma'am, let me come to this once again. When you're talking about subjectivity and polarity, subjectivity means the relevance or the opinion, how strong that opinion is, how factually that information is appealing. So that appeal, that strong, the strength, you can say, how strengthful this particular line has been. So that subjectivity is given to you in the range of 0 to 1. The more it is towards 1, that means the sentence is not very vague or not very random, it is very appealing, it is very strong. The strength is represented by the sequence of words that you are using. So अगर आप कुछ random words use करेंगी, ये polarity भी कम हो जाएगी, subjectivity भी कम हो जाएगी, क्योंकि आप उसमें से पता नहीं लगा पा रहे कि कितना strong है. यहाँ पे जब हम ये sentence use कर रहे हैं, I hate NLP, तो ये बहुत ही strong opinion है, बहुत ही strong information यहाँ से आ रही है कि कुछ distaste है, कुछ disgustness है किसी चीज को लेके, कोई एक awful सी फीलिंग है, बैड सी फीलिंग है जो कन्वे हो रही है. तो सब्जेक्टफुली ये बहुत ही अपीलिंग सेंटेंस है जो कुछ बहुत जरूरी इंफॉर्मेशन दे रहा है. तो दैट सब्जेक्टिविटी इज रेफरिंग टू वेरी स्ट्रॉन्ग इंफॉर्मेशन दैट इज बीइंग कन्वेड बाय दिस. अगर आप आई लव एनएलपी करेंगे यहाँ पे, हाई हेट की जगह लेट मी पुट इट आई लव, then in that case again sentiment की polarity positive की तरफ आ गई है, 0.6 है, and subjectivity भी 0.6 है, that I love NLP. okay, नेगेटिव में जब जाते हैं ना, तो पोलैरिटी और सब्जेक्टिविटी थोड़ी ज्यादा हो जाती है, क्योंकि ओपिनियंस, नेगेटिव ओपिनियंस बहुत स्ट्रॉन्ग मानी जाती है, पॉजिटिव ओपिनियंस लाइकनेस मानी जाती है. लव, लाइकनेस इज टेकन टू बी ओके, पॉजिटिव है, अच्छा है, पर स्ट्रॉन्ग अगर आप स्ट्रेंथ में बोलेंगे तो नेगेटिव फीलिंग्स को ज्यादा स्ट्रॉन्ग माना जाता है, डिस्टेस्ट को ज्यादा स्ट्रॉन्ग माना जाता है, जबकि लव और हैप्पी वाली फीलिंग्स को यू काउंट देम अ बिट लेस, कि ओके खुश है ना, ठीक है, अच्छा ही है, तो ठीक है रहने दो. लेकिन अगर नेगेटिव की तरफ है तो बहुत स्ट्रॉन्ग है, उसको काउंटर करना ज्यादा जरूरी है. तो इसलिए वहां पे नेगेटिव में टर्म इज मोर हायर, सब्जेक्टिविटी इज मोर हायर. Okay, so I hope that that part is clear ma'am. Yes, who was asking? Yes, Ramita ma'am, is it done? Okay, thank you so much, thank you for the check. Okay, now I am coming to the complete project. Like, I'll be giving you this project, but I'll be taking up this quickly. So this project is about text classification in NLP. So what I have done, I have tried to combine two things. I've tried to combine logistic regression model of machine learning, and I have tried to combine natural language processing, and I'm creating an NLP pipeline based on all the concepts that we have done so far. We have talked about vectorization, we have talked about tokenization, all the all that stuff we have talked about. So I am creating an NLP pipeline, and I am training a model which is based on logistic regression and vectorization that will be creating, and then directly we will be classifying our text. Okay, so the data set for this text that I am using is 20 news group data set. Okay, so I have already opened this data set for you. Let me see, where is it? Yes, so this is, Scikit learns one of the good data sets, one of the predetermined data sets that we have. So here you can see I'm just giving you this link also, so that afterwards if you require this data, you can use this data set also, right? So I have shared the link with you for this data set. This is 20 news group data set. So this data set is all about 20 different sections of the types of information that we can have in news groups, or news, you can say news posts, or 20 different themes that we can have in news, right? So we can have, like, these are the 20: ethism, graphics, then hardware related, for sale, motorcycles, baseball, hockey, something related to cryptography, electronics, medicine, sciences, then space, religion, okay, politics, Middle East, miscellaneous related to politics and religion. So these are, different 20 different themes that are present in this 20 news groups data set. So you can say these are also the classes, these are the different class of information that you have. So what we are trying to do, we are trying to train our model using certain text. The text is present in this data set. We are training our model, and then we will give our own new text just to classify that where our given new text stands. Okay, what class the model can predict for our new text. Okay, so that is going to be our project. So let us go about it. So I'm going to use this complete text classification project. So first, scikit-learn.dataset. So because since this is the predefined dataset, so I'm using the scikit-learn's datasets library, through which I'm directly importing this, and I'm not using any pandas library for it. Okay, I just wanted to use a simple application. Otherwise, if you have another dataset, a text-based dataset through which you can, uh, you know, uh, train your system, then you can use pandas library and import that in your system, and then you can use a train test model, right? So Abhi, in this particular data set, I'm simply using uh, scikit-learn.datasets import fetch 20 news groups. So I'm using fetch 20 news groups in the name of this data set, right? From scikit-learn.model selection, I'm importing train test split. So I'm using machine learning scikit model, scikit-learn, and through that I'm using model selection and train test split, right? So now I'm using the load data set. I'm trying to load this data set into this news groups. You can say news groups, a variable that is pointing to a subset of this news groups, where I'm taking everything, I'm taking all the 20 categories, but I'm removing any headers, footers, and quotes, because this data set contains specific subcategories also. So I'm removing every other thing. Just I'm taking is all the 20 subset categories, all the 20 news group categories. Otherwise, I'm just removing all the headers, footers, and quotations which are present inside this data set, right? So I'm using this load data set. Then I am dividing this data set into two parts, which is independent and dependent variable. So independent variable is going to be all the independent columns that I have in my data set, and y is going to be the target or the class column that we have in the data set, right? So you can see this data set contains x values of, okay, if I can show you here the details of this data set. Hmm. If you want to see this data set, I think yes, original 20 news data sets. This is a website that it has 20 news groups. Okay, so these are the 20 classifications or 20 groups of news that you can have. And if you want to download the data set, if you want to download the tar file of this data set, then you can do that through this link. Okay, or zip file, then you can use gunzip over here, right? So I'm just giving you this particular link also if you want to see the data set, right? Okay, so I've given you this complete thing. Where is it? Mhm. Yes. So this is our data set, right? Now it has if I could show you this data sets columns, then that would be helpful for you to understand. But it will take time for the star file to. Okay. Let me open on Kaggle 20 news group data set. Kaggle. Yes. Because most of the data sets we get on Kaggle and we can view a part of this data set very, very easily. Okay. So you can see this entire, we have entire list of all the 20 domains that we have, right? So we have this entire list, and this is list.csv, which actually contains this thing. So you can see this is a document ID that may be containing, and this is the news group that it is actually containing. So you can see this is the news group, and it is, according to this document ID, it is giving value. So it is giving one value. So okay, anyhow, we can talk about this data set later at some other time. Anyways, so you can understand this particular thing, that this data set contains, different news text related to a particular domain, and the target or the class of that text is given by the name of that, the type of the domain. For example, it could be for sale. If you see this for sale, then for sale is going to be your news group. So news group itself is the target, that is miscellaneous dot for sale. And you can see this is the information that it is containing. Suppose I'm looking for an expensive motorcycle, so this is the text that it may contain. So both for sale, so you can see these are news clippings or advertisements for, related to some automobiles or motorcycles, asking for 15,000 or best offer, contact Gerald. And here we have wanted, brother Peter, as it says, I'm interested in buying for little label marker. So you can see these are different informations which are related to the motorcycle news group. Okay, so I just wanted you to understand what we are actually doing. We are actually classifying the text, okay, on the basis of their class labels. The class labels may be these, they may be motorcycles related, they may be electronics related, they may be space related, sci-fi related, and so on. So here, when I say X contains all the other columns which contains the text part, all the other features, all the other columns. And Y is the target. Target means the class label, the class classified or the class label information that you have for that text. I hope I'm able to, make you understand this particular thing, right? Okay. Now splitting this into training and testing data, because for applying machine learning models, we need to split our data into four categories. X will be split into two categories: X training part, X testing part, and similarly Y will be split into Y train and Y test part. So we are using train test split class, and we are sending this X and Y. Test size is 0.25. That means 25% data is going towards the test part, and 75% of the data stays in the training part. Random state in general, we can give any. I can give 0, 1, 2, 10, any value you can give. So I am giving this current representation of splitting as random state 42. So every time I am using this 42, that means that split 42 is being used. Okay, that naming is done as 42. So I'm just giving you this code. You can run this code and try to load this data set into your system. Okay, so I hope you are understanding this thing. Okay, just check and try to implement this. Now, we have done this simple. We have loaded a data set. We have splitted that data set into training and testing data. Okay. So now we are going to apply vectorization on the test part, because you can see, as I showed you on Kaggle, this is simple text. Okay. These are so, factual text that we are having. These are some information related to, for example, this is about this news group is about sky space. Okay, so this is scientific or space related information. So there are so many informations over here. So we need to vectorize this, entire text. We need to vectorize things. So what I'm going to do, we are going to create a TF-IDF vectorizer. So we are creating a vectorizer object. We are calling that same TF-IDF vectorizer, right? And now we are going to apply this vectorizer object on our training data set, right? So we are going to apply vectorizer fit transform or on the X train data, right? So we are applying this on X train, and what we are creating is X train TF IDF, right? So we are vectorizing it. We are creating term frequency and IDF inverse document frequency. We are creating that documentation, that vectorization on the basis of the number of occurrences of the words in the entire document, right? Based on that. Now, similarly, we are also applying this transformation on the test data, because then only we will be able to model the trained data and test the test data. Okay, so we have to do that. So X test TFDF we are creating, and we are applying this vectorizer object on this X test also, right? So we are transforming. Just remember that the rule of machine learning says you will fit and transform the training data, because you want to create a model from your training data. You want your model to fit your data, right? But you will only transform, you will only apply the structure, the transformation part, the numeric transformation part to the test data, but you will not fit it, because fitting means applying to the model. The learning will begin in the fitting, but only test data is just transformed, it is not fitted. You want to check, you want to test, आप सिर्फ टेस्ट करना चाहते हैं अपने टेस्ट डेटा के साथ में, तो आप उसे फिट नहीं करेंगे, मॉडल को अप्लाई नहीं करेंगे, ठीक है? I hope ये सब बातें आप लोगों को already, you are learned people, you may be knowing all this stuff, right? Okay, just for the recap, I'm just telling you that. Okay, now ultimately the next thing is to create an NLP pipeline. Now we are actually creating a model, we are creating a pipeline for our system. So model equals to make pipeline. We are calling this make pipeline function, right? And in this make pipeline, we are using two different parts. Now, make pipeline, we actually create a pipelining. Okay, you can see a pipeline model being developed. And this pipeline, the first component will be your TF-DF vectorizer and stop words English. That means we are applying English language. We are loading the stop words library in English language so that it can remove stop words. It can create a vectorizer, and vectorization automatically creates a tokens. It automatically removes stop words, creates lemma. Okay, so TFDF, it automatically does everything. So we are just representing stop words as English, and the model that we are applying is logistic regression. We are just to prevent any warnings, we are giving maximum iterations as 1000. We are limiting the iterations to 1000 iterations in this pipeline. Now finally it is time to train the model. So we are fitting the model. So model equals to model dot fit, and we are fitting the model on X train and Y train. So we are giving the X training data, and we are using the Y training for prediction, and we are checking things. So this is your pipeline that is created. So you can see over here, I have extended this pipeline. When you are applying this pipeline, you are applying TF-IDF vectorizer, and you are applying logistic regression model with maximum iterations of 1000. So you can see TF-DF being worked upon, stop words being loaded, and here logistic regression being implemented, right? So this is just the explanation of each and everything that I am applying over here, right? Okay. Now we have applied the model, we have fitted the model of logistic regression, and we have fitted the model for TF, IDF, and LP. We have combined these two things to create a pipeline. Now the point is how much accuracy we are able to achieve when once we have applied our model on X train and Y train. The next part is we need to predict things, and we need to match things with Y test. So let us go for the prediction part. So from scikit-learn.metrics, we import accuracy score. That means we want to, import the metrics, the accuracy score and classification report for us. Now we want to do some prediction. So Y prediction equals to model.predict X test. So what we are trying to do, we have used that model upwards, right? We have already created that model over here. The model was created with the help of this pipeline. We have already created this model, and now we are using this model to predict things for X test. So now this model will actually predict values, y values, the class labels, because this model is already trained on X train and Y train. It already has information. It has learned information on how X data is being classified for Y information. So it already knows that information, right? So now this model is a good learned model. So now it can predict things for us. So we are using predict function for this X test, and this is going to predict values and store them in Y prediction variable, right? So it will be in the form of list, obviously, right? Now we are predicting on the X set. So what we are doing, predict on X set. So pipeline dot predict. So now we are using this pipeline also. We have used this pipeline we have created. Again, above we have created this pipeline when we were creating make pipeline, right? So we have created this pipeline dot predict X test. So we have this y prediction. So we are predicting on the test set. So now what we are trying to do, just understand this thing. We can predict on the basis of this pipeline, and we can directly predict on the basis of model also, right? So now if we try to find out the accuracy score is the comparison between how much correct predictions we have done by matching our predictions to the test part, right? Because already we have this y test information stored with us. By prediction we have predicted on the basis of our test set. So now if we predict this, we can get accuracy. So accuracy we are getting around 76%. Okay, so this is predicting on the basis of pipeline. So what I'll do, I'll just take it one by one. So I'll just run this for you again, right? Let me run this code. And in the meantime, you people also create this vectorizer and create this pipeline. So I'm just giving you this entire code so that you can implement it at your end, right? And you can create a pipeline from that also, right? Okay, so yes, implemented. Now this one. So I've given you the code. Please implement that. It may take a while for implementation. Okay. Creating a model may take some time. It takes a few seconds, or range of 2-3 minutes it may take, because it is iterating 1,000 times for logistic regression. So it may take some time, right? I hope you people are able to create the pipeline. I have also done it so that I can show you some differences in the model building. Okay. So it may take a while. Are you able to do? I hope you people are able to do this. You are not facing any trouble in implementing things. It may take a while. We can wait for 2-3 minutes just for this implementation. Okay, now it is done. It is completed. So this pipeline is created, right? So I've implemented this, and now the system is updated. Now I'm just commenting this pipeline part, right? And we are trying to do it on model predict, right? Just see this. When I am just implementing on the model was this one, where we were creating this pipelining and we were applying this model. So just to put it in pipeline, not only on the model, but just to put this pipeline prediction, we have to do this statement. Y predicts equal to pipeline dot predict. Now that pipeline prediction should be done on X test. So now if I implement this, I'm going to get a bit of more optimized, you can say, accuracy, which is 76%, because now the pipeline is being used to predict for X test. Okay. Previously it was only the model, the trained model that was being used, but now you are trying to predict with the help of this pipeline model, right? Not only the pipeline, not only the model alone, but the pipeline that you have created above, that is being used to predict for X test. So it is helping you to optimize and improve the accuracy from 73% without using pipeline. If you don't use pipeline and you implement this, you are going to get 73% accuracy only. But if you use pipeline to predict, not the model alone, then you can optimize that accuracy. A better result you are achieving for 76%, right? So accuracy score, you are testing it for Y test and Y prediction, and then you are printing the accuracy. And classification report also you are printing for Y test, Y prediction. And target names are newsgroup dot target name. So you can see over here we have these 20 target names, and for each and every target name we can see how much accuracy we were able to achieve, how much precise recall information, F1 score. All these are metrics of machine learning just to see how better that class has performed. So you can see over here precisely this hardware 85% times this hardware was precisely or with precision this has been predicted. So that means it has predicted more of the positive results. It has predicted for hardware category, and more poor results for ethism category, right? Because it is only 67% precision that we have. And recall also you can see for baseball again we have 89% times precise precision and recall is working positively towards it. F1 score is also high. So that means you have achieved maximum accuracy for baseball and for cryptography or crypt information, right? 91% of precision, 80% recall. So this is the overall thing. So overall accuracy that you are able to achieve is approximately 77%, which is 76.80. So you can round it off to 77% accuracy. All for all the 20 categories you are able to achieve it, right? So now it's time for prediction, because we have already created pipeline, we have trained our model, we have seen the accuracy. Now we can predict something, right? So what I have done, I have given some sample text for prediction. Okay, so I just give you this code. You can just check the accuracy in your system, like how much accuracy you are able to achieve on your systems. So I have given you that complete code. Okay, you can just try to implement that. And prediction also I'm giving. So see this example prediction. So the example text I'm giving is the space shuttle launched successfully from Kennedy Space Center. So this is like a news, you can say news headline that I'm giving, for example, and I'm trying to predict that category. So what should we do? We should create a variable predicted category, and here we have to use pipeline. Again, we should not use model alone, rather we are using this pipeline dot predict. Okay, so we are using this pipeline dot predict, and now this time I'm sending this example text so that its category can be predicted. Okay, so predict category name equals to newsgroups dot target names predict category 0. So whatever the value has been predicted in predict category, it will be coming in the first position. So that is why we are trying to retrieve the predicted categories first, 0th position, right? So now it is printing the predict category name. So you can see as I run this code, once again I run this, so it is giving me sky space. Sky space means it is something related to science fiction and space category. So it is giving me sky space. So this is obviously the correct category, the correct prediction is happening. Okay. Now, since we are able to achieve only 77% accuracy, so it may give you wrong results also. So let us see next example text, where I have given the headline, the stock market is at all the high time or the time high, right? So now if I try to predict for this, if I'm trying to predict for this, if I run this now, it is giving me motorcycles, but this is not related to motorcycles. This is related to something market or politics. So this stock market is all time high. This headline is not being correctly classified into its correct category. Rather, it is classifying into wrong category. But since it is 77% accuracy, so we can expect wrong results also, right? We can optimize it using other models, large language models, and so on. We can optimize things. But as of now, you can see the news categories that you have, they are being categorized. Sometimes it is wrong, sometimes it's correct. and optimization is always the key. So you can optimize it using transformer models. Okay, anyhow, let's go ahead. So next I have
Good
used
afternoon, ma'am.
yes,
Ma'am,
yes,
may I ask a question?
yes, Dr. Shani, yes ma'am, please tell me.
Uh-huh. Ma'am, actually, may you have like said this like we have an accuracy for the crypto is 0.91. So why
No,
it's
ma'am. It
happening?
is not. No, ma'am. No, it is not for. It is not accuracy. It is the precision part, and
Okay,
precision
okay, that is
talks
like
about true
okay,
positives over
like
true
in
positives, false positives. Right.
okay, yeah,
Yes,
yeah.
ma'am.
Like in hockey, we have the maximum like precision for 0.95 and the
Yes.
recall is 89.
Zero
And
point eight.
yeah, but why this happens? Matlab, what is the reason behind that? Because we have the sample is almost the same, like 261, 245, 249. So why, like for the NLP task? Why difference comes my question is that because we have all provide the text data, we have give the same trainings to all the uh, reports, but
Yes, ma'am.
sometime it give better precision or recall, and in other samples it give like only 0.67.
Yes.
uh,
Yes. You
so
are right, ma'am.
my question is why this happens with the only with the text, if it is in a data, it will more or lessly same with all the values.
Ma'am, the
And
point is, see, the reason is that because the text is very unpredictable. Text formation is not very properly done. If you see this text, if I show you it on Kaggle, because otherwise it was not visible on Scikit-learn.
Mhm,
If you see it on Kaggle, for say
mhm,
for sale, if we see this text, it may be
mhm.
in a better way, it
Okay.
has been given in a better way. So it actually it is once the text is given or assembled in a better way, it is better to tokenize it, to vectorize it. That frequency and documentation, everything vectorization would be done in a better way. So obviously the entire classification process will be in a better position. But
So my
otherwise, if you see for crypto will be
mm,
more better. If you see this,
yeah.
it is more data, it is categorized. That is why the question part and answering and everything is done in a more better way. That is why when the model is able to learn it and it is able to test it for accuracy, it is giving more higher precision and recall. F1 score is also higher as compared to all other categories because the information is assembled in a better way. Rather than if you see for ethism, if I uh, talk about this ethism, if you take it, then it is like if anything is given without any labeling, there is no label. Sometimes it is given in quotes, sometimes it is some books part, sometimes it is the the sale part is given. So the information is very distributed, or random information is given. So
Ma'am,
more
the data
random.
is very much important to like
Yes,
categorize it in a better way. Like if your data is scattered, the result will be less accurate. And if your data is refined with the proper like
yes,
categorization, the samples are in better way in the terms of
exactly.
precision, recall, or accuracy. So it's
Exactly.
all depend on the data, not with the algorithms.
It all depends on data and the pre-processing. Because ma'am, see, I had very limited time, so I have not gone for entire data pre-processing steps. Otherwise, what would have been done, the ideal way of deploying, if I would have to create a complete project out of it for deployment, then I would have pre-processed this data. I would have removed a lot of stuff from this data which was
Okay.
very unimportant for me. But I did not do that. I am taking the data as it is, without any further cleaning, or without divide or creating rows and columns out of it. I have taken entire textual data itself. I have not divided that data, I have not reprocessed, cleaned that data, no cleansing has been done. So it is good that my algorithm is working so fine that it is giving me 67 for this data, which is very very rudimentary raw data. Otherwise, if
Yeah.
you see other categories, then they are arranged in a very better way. Crypt is arranged in a very better way. You can itself see that the data is arranged in a better format. The formatting is good. That is why recall and precision is going fine. We have a rule in machine learning which say gigo rule. You give golden data, you are going to get golden output. Golden in, golden out.
Fine. Fine.
Garbage
Yes.
in, garbage out. So that
Yes.
is that is working in action that we can see here. Yes, ma'am.
So
Okay.
pre-processing data are very much important, as as per the classification algorithms is also important, but the data cleaning, data gathering is also very much important. Or
Very
one
important.
thing is that, ma'am, like it has
Yes.
like balanced data, but in the real time we don't get the balanced data actually for the text. Like it is news group 20
This is
data shows is
imbalance.
balanced.
This data itself, this category, this 20 news group, this is one of the imbalanced data sets only. That is why I have
Okay.
chosen this, because it is going to give you different results.
Mhm.
But definitely you are right, ma'am. In real time we don't at all have balanced data, because if you are
Yes.
capturing data, if I capture or scrap data from a news website, okay,
Yes.
then I have to do a lot of pre-processing on it, because that data is going to contain much of the irrelevant information from advertisements, also from pop-ups. Some html tags would also come up from my
Exactly.
scrapping. So it is going to be very imbalanced, very rudimentary raw data, and I will be spending a lot of time in pre-processing that data.
Exactly,
And
ma'am.
just
Like pre-processing take lot of time as compared to like building a model.
yes, ma'am, definitely. The 90% of the time we say, we as in data science fields, we say that 90% of the time goes in data collection and data pre-processing. Collection is
Exactly.
also a tough part, and once you get that data in any
Mm.
XYZ format, then pre-processing that data and refining it to be, put in your model is a bit, is a very hell lot task. It's a very time
Yes.
consuming task. It is going
So,
to
ma'am,
take
generative
months.
AI can help us in that manner in
Ma'am,
pre-processing the data. Like it will capture the data, it will create the data, but I don't think it will like pre-process the data so far.
ma'am,
Yeah.
generative AI will not help you to pre-process data,
Mm.
but generative AI can help you to create repository of good data.
Yeah,
See,
I got the
yes,
point.
for example, I just make you understand with a simple example. For example, if we have a very criminal mind and we go for creating deep fake images, okay. Now for
Mhm.
deep fake images, if I want to create, I will have to train my GAN, my generative adversarial network. I need to train my GAN model with, huge bulk of images, so that it can mix and merge image, and it can create something new out of it, or some fake images out of it, some fake human images, some fake building images, places images out of it. For that I need to train my model. But the problem is that, you know if human images are to be trained, nobody is willing to give personal images, personal pictures. So the only thing that we have to do is to gather or generate new images. So for, gather for training our model, we need images, and we don't have images. So whatever images we have, that limited amount of images, we can train them into our GAN model, and that GAN model first of all can generate new images out of it. By mixing, merging features of images, it is going to create new images. Now the new images can be trained into another GAN model to create deep fake images, or to create another set of random images that you actually require for your model, for your application. I hope I'm able to make you understand that
Yeah,
part.
yeah, ma'am. Definitely, definitely, definitely. So my
But it,
concern is only that because in the pre-processing steps, it will take a lot of time actually to work on the text data because it's very simple, like uh, build a model and get the accuracy. But the pre-processes, especially in the text, will take lot of time because the text is much random as compared to data. It has a structure, but
yes,
for the
ma'am.
it is very much unstructured. Thank you, ma'am,
Very,
for
very
your
unstructured data we have. So we, when we do it from social media platforms, or
exactly.
we do it from Facebook, if we scrap that data, or some website data we scrap, we are going to get other, different informations. So we need to
Exactly.
process them, pre-process them.
Okay.
Okay.
Thank you, ma'am.
Okay, thank you so much, ma'am. I hope I'm able to solve your
Yeah, yeah,
query.
definitely, ma'am.
Right?
Definitely. Thank you. Thank you.
Okay. Thank you so much, ma'am. Okay, so we have seen here. Then we go for this and another example. Suppose we go for this: elections are postponed in the country. Now this is something related to politics. So now here no particular country is given, but country, election. These words are, referring to some politic part. So now prediction is done correctly. Our model is able to correctly predict it into politics miscellaneous, talk.politics miscellaneous. And similarly, if see a new iPhone is now in the market. Now again, this is something related to products, some sales in market. So now if you give this text, it is also being correctly predicted to miscellaneous dot for sale, right? So you can see the better data you have, the more better information, the more optimization you do, the more fine tuning of your parameters you do, you're able to get good results. Now I have used logistic regression, and logistic regression model along with NLP is giving me 76% accuracy. If I change the model to say random forest or decision tree or SVM, support vector machine, if I change the model also, then also the accuracy will change. The accuracy will be, much higher for SVM models. For naive based models, they work wonders with text, because already naive base can be used itself for text classification. So if you embed it with NLP, it is going to give you much better results, because it is based on probability, and NLP is also working on probability, the next important word that can come, the next important feature that can come. So both of them together can give you good results. So text classification algorithms, they use naive Bayes and NLP pipelines together. So you can try them out yourself as a, as a project you can create for text classification, right? So I hope this text classification project is clear to you. You are able to classify this text, right? Just give me a check. Any other query we have, any other doubt we have, or just you can give a brief reaction that yes, you are able to do it, right, everybody? So I just give you one of this example text so that you can just, work on this example text and see the classification yourself, right? Okay. Okay. Sonia ma'am, Sonia ma'am, are you here? Hello.
Yes, ma'am.
Yes.
I'm here.
Yes, ma'am. I just need to confirm, like, do we need to close it now, or shall I just give a brief of speech to text and text to speech? Can I give, or shall we stop? As you say, I'll do in the same way.
If you can continue, it's your wish. You can continue with it.
Okay.
We don't have
Uh,
any problem.
we okay. I'll just take okay. What I do is I just give you a glimpse of how speech to text and text to speech works, so that you have that. Okay. Manoj sir is asking, like, can we be having the recording of this? Can we'll be having the recording now? I think,
Yes,
ma'am,
we
we
would
are
be
having the.
sharing. Yes, everyone, we would be sharing you the link of the recordings. You can access through that link. Every session recording link would be shared with you.
So, so ma'am, I am just taking next 10 minutes to, to cover up the speech to text and text to speech, so
Sure.
that, that is the main part that everybody should definitely go for that. Like, we can create our own language translators, the Google translator. What it is doing, we can use that API and create our own translators for our websites, for our applications. Okay, let me just discuss that speech to text and text to speech very quickly with everybody, right? Okay, so this is a speech to text application that I've created for you. I am using speech recognition library, and I'm importing that as SR. Okay, this is the alias name that I'm using. I'm using tokenizer also. I'm using sentiment intensity analyzer also, just to check the intensity of the speech that I'm using, right? And just to check the sentiment also for the speech that I will be using, okay, on the runtime. Similarly, I am using Punket, that we have already downloaded earlier also. So here also for this project, I am just downloading Puncti and Vader Lexicon for, for lexical analysis of the data. So for that, I am using these two libraries. Now I have created this complete. Once you do this, okay, it is going to give you true if all the download is happening successfully, right? You will be able to do this. I will be sharing this entire code for you, this project with Sonia ma'am, and she will be sharing with you all. So I'm not, giving you this code as of now. I'm just covering this up quickly for everybody. Okay. So now the function that I've created is recognize speech from mic, where I will be speaking something, and my mic will be taking up or catching up my speech, and that speech will be recorded or taken up by the system for its further analysis, right? So here, this function, entire function is recognizing the speech and capturing the speech from microphone. Okay, so the source is microphone that I'm using, adjust for ambient noise. So that means any noise cancellation if required will be done. Any ambient noise or any small noises that are happening in parallel, they should be, adjusted by the recognizer. So it will be listening to what I'll be saying. So successfully, if if some error is happening, then it will be giving me some error information. Otherwise, it will give you true or success information, right? Okay, so this was done, and the transcription or the recognition or the internal processing is being done by Google. So I'm using the recognize Google API. So I'm using recognizer.recognize Google and audio, whatever audio it will be listening, whatever speech it will be taking up, it will be transcripting or converting that into numbers, into bits and bytes that my system can understand, right? And also, if that API, the recognized Google APIs will not be available, then it will be giving me a message that API is unavailable, or it is not able to recognize any speech. Suppose I don't speak, I just play some music or I just do some other noise, then in that case it will give me any errors that unable to recognize speech, right? Okay, so this is my main code where I am now creating the objects for recognizer and for microphone. Okay, so I'm just creating the recognizer object. By speech recognizing library, I am calling the recognizer class, and similarly from speech recognizing library, I'm calling the microphone class, which is going to create the microphone object. It will ask me to speak, it will recognize speech from mic, it will call this function recognize speech from mic. Recognizer and microphone, these two objects will be put in as input parameters, right? That means the speech recognizing library is ready, and my microphone is also ready to take my speech. Okay, in response success, now it will pass, if the successfully, if it has taken my speech successfully, then it will pass the success message. So if the response is success, then it will say you said, and all that transcription will happen, and tokens will also be printed, and sentiment will be calculated by the sentiment analyzer. So it will give me polarity scores also. It will give me the entire sentiment results that we had just seen from text below. So I'm now not using text below, I'm using sentiment intensity analyzer class for this. So here, suppose I just play this for you. Just hold in for a second. I run this code, I run this code also, and now I run this code also. Okay. Hi friends, I am very happy with all of you. My audience are so good. They are so patient audience. I am so happy to deliver this training to all my audience. Okay, so just see guys, whatever I spoke, it has taken all those things, it has recorded that thing. So you see here, it was first of all listening. As I stopped, it paused for some seconds. It waited for me to speak more, but I didn't speak, so it interrupted, it ended its listening process, and it is printing now. Hi friends, I'm very happy with all of you. My audience are so good, so patient. Whatever I said, it has taken that. It has created all the text on the runtime into tokens, so it has tokenized it, and it has created a sentiment. So sentiment is neutral sentiment is 0.63, that means 63.7% neutral. Positive 36.3%, where I have used the word happy, patient. So all these are the neutral and positive words. So all over, the compound sentiment is 0.94, which should be between 0 and 1. More sorry, minus 1 and 1. So more towards 1, it means more positive. So compound 0.94 means more of a positive sentence I have, more of a positive sentiment I have. Okay, fine. So I hope you have got it. Now it has done one thing. It has converted the speech, whatever I spoke, it has converted that speech into text. Okay, and it has also calculated the sentiment from it. So sentiment analysis is also done, and similarly speech to text translation is also done. So this is transcription or translation that we have done. Okay, so this is a bit of explanation that I have given. Now the next code that I have is for language translator. So language translator, I need to first of all install speech recognition Pi Audio Google Translator. Okay, this API I need to install in my system. So once it is installed, it will take a bit, some minutes to install. Once it is done, again, you can use speech recognizer library, tokenization, sentiment analyzer, and Google Translator. As you have to use this Google Translator library that you have imported here, that you have installed, and now you are importing translator library from Google Translator. Okay, this is important. Otherwise, Puncti and Veda lexicon that you already need to update your libraries, you can do that, right? Okay, now again the same thing, recognize speech from mic. So it is going to recognize the same code that I had used earlier, recognizing speech from mic, where recognizer and microphone were being used. It will listen whatever I will be speaking, so it is going to do that. Now translation will be happening. So translate text, so whatever I will speak, that will be translated into any target language. So I have written that function translate text, text comma target language. So here we are creating a translator object, and we are giving a destination target language. So target language I am going to give at the runtime. Okay, French है, Spanish है, हिंदी है, जो भी language आप चाहेंगे आप वो यहाँ पे दे सकते हैं. So यहाँ पे देखिए, next हमने recognizer का object बनाया, microphone का object बनाया. It will ask me to speak. Whatever I will speak, it will transcript this. It will create, it will calculate the sentiment of it, the same code that I had used previously. The additional code is translate the text. So here I can give, ES for Spanish, FR for French. We have a lot of, I show you here. Here we have Google Trans library has so many languages, 50 plus languages that you have. In fact, 100 languages, I think. Now, yesterday I updated this, so it is giving me 100 languages. Hindi also is a part of it, Bengali also is a part of it, Kannada language, Latin language, and Burmese language is also there, Mongolian, Marathi language, Indian languages. Many Indian languages have been included. So Odia language. So I think now you will be able to understand now how quickly they are able to convert the languages, convert the website into different languages. So the crux is this. The crux is this, how it is using. Okay. So anyhow, I am now using Spanish language. So it will convert whatever I will speak, it will convert that text into Spanish. Okay. So I'm just playing this code. For that, I just need to play this one. No. This is already installed. Okay. So I may not be needing to install this, but I need to play this. Okay. Done. This is done. This is done. And now this is done. Oops. I play this again. Hello all my audience. It has been a great session with you all. You can see here, it has first of all listened to what I said. It has printed all the text. Hello all my audience. It has been a great session with you all. Converted it into tokens, calculated sentiment. So overall compound sentiment, it has nothing more positive, nothing negative, but neutral 72%. So compound sentiment calculated at 62%. So 62% means neutral, right? So translated text into Spanish is hola, toda, whatever. I don't know Spanish, so I won't be able to speak it, but my machine will speak it for you in a while, right? So similarly, I can just, convert that into French also. So if you same way, just change ES to FR, so it will convert to French. Whatever you will say, it will convert to French. If you convert it into Hindi, if you want to convert it into Hindi, just change the target language to HI. HI stands for Hindi. So it is going to convert it into Hindi. So for example, I run this. Hello, all my audience. Oh, I just need to run this once again. Hello, my friend. Welcome to my home. ये देखिए, आप देख सकते हैं हिंदी में इसने ट्रांसलेट कर दिया आपके सामने। हेलो मेरे दोस्त, मेरे घर में आपका स्वागत है। तो जिस जिस चीज को ये हिंदी में कन्वर्ट कर पाएगा, ट्रांसलेट कर पाएगा, करेगा। नहीं तो इंग्लिश को ही हिंदी में लिख देगा। जैसे हेलो है, सो हेलो को इसने हेलो को हिंदी में लिख दिया। उसके लिए उसने नमस्ते नहीं करा। तो ये थोड़ा डिफरेंस है। आप अपना सॉफ्टवेयर बनाएं, अपना काम करें, तो आप ट्रांसलेट कर सकते हैं पूरी तरह हिंदी में जाना चाहें तो। एनी हाउ, the translated text is hello मेरे दोस्त, मेरे घर में आपका स्वागत है। So you can see the power of Google Translator, जो वो कर रहा है गूगल पे, हम अपनी वेबसाइट में, अपनी एप्स में उसको इंटीग्रेट यहाँ पे कर सकते हैं। ठीक है, सो ये लैंग्वेजेस थी। द लास्ट थिंग, फाइनल थिंग इज दैट इफ यू नीड टू गो फॉर टेक्स्ट टू स्पीच, अब आप कुछ टेक्स्ट दें और वो स्पीच में कन्वर्ट हो, आपकी मशीन बोले आपके लिए इंग्लिश में, फ्रेंच में, स्पेनिश में, गूगल ट्रांसलेट करे उसको, तो वो भी आप कर सकते हैं। तो उसके लिए द लाइब्रेरीज दैट वी नीड इज PyTTS, XX3 and GTTS. So these two are the libraries that you require for, these are again Google API में है, ये libraries directly install हो जाती हैं, so you can directly work with them, right? So GTTS module को हमने import किया। यहाँ पे मैंने कुछ टेक्स्ट दिए, जैसे वेलकम ऑल ऑफ यू टू पाइथन क्लास एट 1 to 3 PM टुडे ऑन 23rd July 2024। ये है लैंग्वेज इंग्लिश। ऑब्जेक्ट मैंने इसका क्रिएट किया है, माई ऑब्जेक्ट। GTTS को डायरेक्टली यूज कीजिए। text equals to my text, language equals to language, slow equals to false. You don't want it to be slow, you want it to be normal pace पे। so आप जैसे ही इसका ऑब्जेक्ट क्रिएट करते हैं GTTS का यूज करके, GTTS डायरेक्टली कन्वर्ट कर देता है आपके टेक्स्ट को ऑब्जेक्ट में। तो जो टेक्स्ट आपने यहाँ पे दिया है, टेक्स्ट इक्वल्स टू माई टेक्स्ट, दिस विल बी कन्वर्टेड इनटू एन ऑब्जेक्ट, एंड दैट ऑब्जेक्ट यू कैन सेव विद द हेल्प ऑफ सेव फंक्शन MP3 के फॉर्म में। तो आप जैसे मैंने यहाँ पे MP3 मैंने नाम दिया वेलकम 11.mp3, तो ये इस नाम से करंट रैम में जो करंट डायरेक्टरी है वहां पे सेव हो जाएगा। और अगर आप इसे प्ले करना चाहते हैं तो OS मॉड्यूल का यूज कर सकते हैं, os.system welcome.mp3 का आप यूज करेंगे तो आप इस फाइल को प्ले कर सकते हैं। ओके, जैसे मैं मान लीजिए कुछ और टेक्स्ट देती हूँ यहाँ पे, वेलकम टू ऑल ऑफ यू टुडे 23rd July, it was a great session with my audience. Okay, so suppose I give this one and I don't need to install anything else. Yes, okay, fine. So I run this for you and देखिए आप इसे इंग्लिश में सुनिए पहले।
Welcome all of you. Today on the 23rd of July 2024. It was a great session with my audience.
I hope आप सुन पाए हैं। Sonia ma'am, can you give me a check? This audio clip was audible?
Yes, it was audible.
Yes, okay. So you have seen this, that English में इसने पढ़ा इसी टेक्स्ट को। अभी इसी को let us try to do it in French and Spanish. So I'm now converting this text to Spanish. So now it will speak for you this thing also.
Now converting this text to Spanish language.
Okay, so now I am giving this text once again. Welcome all of you to Python class 1 to 3 PM. मैंने ये दिया हुआ था, तो मैं यहीं पे वापस से यही ले रही हूँ। ठीक है, या फिर हम इसी को ऊपर वाला ले लेते हैं, ये वाला। Let us take this text and let us convert that into Spanish. I don't know Spanish, but our system knows every language. Okay, so now let us play this into Spanish.
Welcome all of you, today on 23 July 2024. It was a great session with my audience.
Whatever it could convert, I just feel कि इसने सही किया होगा। Spanish अगर कोई जानता है, so he or she can evaluate that, but I think it is doing in a better way. Okay, so now converting it into French language.
Now converting this text to French language.
Okay, so I am playing this again into French. इसको French में भी कर लेते हैं, and that's it.
Welcome all of you, today on 23 RD July 2024. It was a great session with my audience.
So genre थोड़ा different था and it has done it. So I hope थोड़ा आपको अच्छा लगा होगा. You would have felt good by seeing this, that yes, our system can convert things. Might be you all have already done all those applications. So I think, Sonia ma'am, from my side this was all. Rest, if anybody has any questions or any queries, please, I welcome all your queries and questions, but that was all from my side.
Any queries, anyone? You can raise up your hand so that we can give you the mic permissions.
I think Dr. Madhvi has a question. She's saying that if possible, we'll need one whole example of project that is run now of a single project. Yes, ma'am. I think one you can do them in a single project also, and in a different projects also. I have done it in a single Jupyter file, but you can do them in different files also. If any other query, then you may allow Dr. Madhvi to ask a query.
Dr. Madhvi, any other query? We have allowed you with the mic.
Yeah, the session was really very good. I hope I am audible.
Yes, ma'am,
Thank
you're
you.
audible.
Yeah, and actually, I am teaching this subject information retrieval, and I have taught all these things. So I really enjoyed the same again, and lots of new things. So the thing is, if we get one example of any one project along with the code, we'll be happy to run that maybe.
Okay, ma'am, not an issue. I'll be
That's all.
sending that form, that
Sure.
document to Sonia ma'am in the form of the project, like
Okay.
one project, and then you can directly run that. I hope that
Sure.
makes
Sure.
sense, ma'am, right?
Yeah. Yeah. Thank you. Thank you so much.
Thank you, ma'am. I hope you enjoyed the session, ma'am. Thank you so much.
Yes. Yes.
Thank you. Thank you,
It's
ma'am.
really very good and interesting. It was interesting.
Thank you, ma'am. Thank you so much. Any other query we have?
Any other queries or any feedback you can put up in the chat window? We are open for your feedbacks.
Ramita ma'am, thank you so much. Ravinder sir, no, I am I am not doctor. I am not doctor. Ravinder Kajal sir. रविंदर सर तो मेरे टीचर हैं. He has been my professor.
Okay.
Yes.
It was a very, very nice session, Nidhi ma'am. We all enjoyed a lot. We have learned so many things.
Thank you,
And
ma'am. So much.
obviously, every time when I have your session, very curious to learn about any other new thing. And yes, every time what we get are something different from your side. Thank you so
Thank,
much.
thank you, ma'am.
Thank you so much
Ma'am,
for
can I
sharing
share
that
my
with this
LinkedIn?
time. Yes,
Ma'am,
yes,
can
ma'am.
I
You
share my
can share.
LinkedIn?
Yes, yes, sure.
Okay.
You can share up your
So
profile.
I'm sharing my LinkedIn profile. Like if anybody wants to connect, do connect with me. It will be really nice to connect with you all, with so many learned people. So I'm sharing my LinkedIn ID. This is my LinkedIn handle, okay, with my name Nidhi Grover Heja. So I'm sharing this on the chat window. I just request everyone to stay connected. So I'm sharing my ID with everybody. Please be connected. It will be really nice to have all of you, all of us, in fact, in the same platform. It will be very nice for sharing insights, for sharing knowledge and information together. So LinkedIn is a great platform to stay connected. Thank you so much, Sonia
Thank you
ma'am.
so much, ma'am. Thanks a lot. Waiting for your next
Anytime,
next
ma'am.
session with you. Waiting for another informative session with you. Now, another session one to one. Okay, not in online mode.
Definitely, ma'am. I'll
Okay,
be waiting too. Definitely.
thank you so much. Thank you, everyone. Thanks a lot for the day. We'll
Thank
be
you, sir.
again
Thank you, sir.
back
Thank you,
tomorrow.
ma'am.
We'll be again
Yes.
back tomorrow with another informative session by Mr. Munna Pandey. another technical trainer. So meet you all tomorrow morning at 10 o'clock. Thank you so much. Thanks a lot.